Who was Paul Dirac?
Ooh, Paul Dirac was a 20th century physicist, 19th and 20th century physicist, responsible for a variety of things. One of those things being quantum mechanics. So the Nobel Prize for quantum mechanics went to three people, right? Schrödinger, Heisenberg, and Dirac. Everybody knows Schrödinger and Heisenberg. Nobody knows Dirac. That is why we named the company after him. I was reading the biography on Paul Dirac by Graham Vermello called The Strangest Man. And I thought, wow, that guy's awesome. Very shy, very interesting, a little bit reclusive. Everybody knows things that he's contributed to the world, but not everybody knows his name and attribution to that. People know things like have you ever heard of the delta function?
Mm-hmm.
Right? That is the Dirac delta, actually. And so, things like that. Things like, have you ever heard of the positron?
I have not.
So the positron is, it's an elemental particle. Dirac actually predicted its existence with his, Dirac equation. That's again, another one of his contributions. He very, very low key guy, very much deserves to be in the limelight. And, people only know him if you are basically like an electrical engineer or a physicist. And, thought it was a really cool name. Thought we should bring a little bit more light to it. Even more light than it already has.
Yeah, talk to me about Dirac's legacy, and then obviously you are the founder of Dirac. Why was it the right symbol for the company that you're building?
Well, if you integrate a delta function, you get a step function. And so we think that over time, what our company represents is a step function improvement in the quality of life and the productivity of the modern American manufacturer. So that to us feels very apt. That's not the only reason that we named the company after Dirac, but feels really symbolic. We also think that when it comes to problems in the world of engineering and manufacturing, everybody knows, very similar to how the Nobel Prize for quantum mechanics went to Schrödinger, Heisenberg, and Dirac. Everybody knows Schrödinger and Heisenberg. Nobody really knows Dirac. Very similar to that. In the world of engineering, everybody knows problems for engineers, and everybody likes to build and solve problems for engineers. So software engineers talk to mechanical engineers, design engineers a ton. And so there are tons and tons of solutions out there built for folks on the design side. And there are not that many on the production side. A lot of the tools that are built for manufacturing are very old and archaic. And the tool set that we are automating for and upgrading immensely, a lot of those tool sets are basically PowerPoint and Word documents, and that is the current state of global manufacturing, not just American manufacturing. But I would say that is why I would say that the moniker of Dirac for us makes a lot of sense, just because the delta function that we represent in the lifetime of American manufacturing is apt.
Before we get into exactly what Dirac is doing and how you guys are reinventing the manufacturing process, talk to me about reindustrialization. Obviously a huge energy behind this movement, a lot of talk. You are one of the few companies actually building in this space and making it possible. What are the actual bottlenecks holding American manufacturing back, and how are we going to fix them?
Yeah, I mean, there are definitely not just one, right? There are a couple. One of the things that we care a lot about is tribal knowledge, right? So the modern American manufacturer, average age of the modern American manufacturer is like in the late 40s, early 50s years of age. That means that what we call the silver tsunami is going to be happening, which is a lot of folks in the next 5, 10, 15 years are going to be retiring. And because all of the tools that have context or any sort of documentation or information written down are very unstructured, things like I said, PowerPoint and Word, and honestly, most of the information that a lot of these folks have resides in the back of their heads. This is tried and true, 30 years on the shop floor of experience. It doesn't really get written down anywhere. And so there are fewer and fewer people every day that know how to do a very specific thing that is like the underpinning to how a very, very critical process that underpins a lot of our quality of life happens. Every day there is tribal knowledge lost. And what we're building with BuildOS, I'm happy to jump in and just start talking about it. What we're building with BuildOS is not just the first automated work instruction platform. It is a data aggregation, a tribal knowledge aggregation and contextualization platform. Meaning, whenever somebody adds a little bit of context to an assembly instruction in our software, it will automatically get associated with specific components over time. And that is, for us, a really much needed solution, right? In that there are folks who will scribble, if they ever write something down, they'll scribble in the margin of, some piece of paper, or, might be on a post-it somewhere on a bench in the shop, or it's just locked up in the back of their heads. It's just context that they, have through muscle memory. If they're not trying to explicitly explain to someone step-by-step how to do something and not writing it down in that context, it never gets said out loud unless it's literally just said out loud. And that is vital, right? So if we don't retain as much tribal knowledge as humanly possible and do what we're trying to do by bake that context and bake that tribal knowledge into the next generation of tools for American manufacturers, we are in a lot of trouble. So that is one thing for us. It's the flip side to the labor problem. It's the tribal knowledge problem. The labor problem itself is also a really big issue. We're looking at 2 to 3 million unfilled manufacturing jobs over the next 5 years. And what happens when you have unfilled manufacturing jobs isn't just like, I am I'm somebody who runs a manufacturing facility. Like, that's okay. We'll do fine without those folks. Many times, a company will have to either stop producing a certain system, lead times get pushed back, not just like days, but weeks and months, or they end up having to shut down the facility entirely because not only does nobody know how to put that thing together anymore because half those guys retired during COVID, but now, they can't fulfill orders enough. They're losing customers and they end up having to shut the facility down. And so that is why a lot of folks are looking to reindustrialize through automating. We don't want cheap labor. We want smart labor. That is the American way. And that is something that we are generally trying to contribute to, but also get more folks excited about. This was a narrative that was very heavy for, 5-10 years of, they're automating away our jobs. But now I would say the past couple of years, ever since COVID, everybody, even the folks who have been, or the gray hairs who've been on the floor for, 30, 40 years, even they are saying like, okay, this is getting really dire. We got to start automating some of this stuff. And so that's not automating the intelligent, high skill stuff necessarily. It's automating like the dull, dirty, dangerous grunt work that like nobody even really likes doing. So, yeah.
You talked about capturing the tribal knowledge. Walk me through what work instruction creation looked like before Dirac. Why is this process so broken? And why did nobody build software for this before?
Yeah, absolutely. So the process of making work instructions today is basically what it looked like many years ago. It is basically when a manufacturing facility is tasked with making a thing, right? A mechanical engineer has designed some system, CAD'd up an assembly, for example. CAD software is prolific on the engineering side for mechanical engineers. So nowadays, a mechanical engineer will CAD up some assembly, will design it, they'll make a 3D model of it, and then they will say, job's done. I'm going to throw this over the fence to some dude at the factory. That person at the factory, whose job it is to figure out how do I actually turn this platonic ideal of this solid or this platonic ideal of this thing into a real thing. How do I take this concept and make it like a reality? That person is called a manufacturing engineer. So the manufacturing engineer is sort of this like blue collar equivalent to the white collar mechanical engineer who's just living behind a 2D screen, very frequently designing something 5,000 miles away from where it's actually built. And that is like the state of the modern manufacturing facility. It's the guy who is designing the thing lives far, far away from the factory where the thing's actually built. And so mechanical engineer throws CAD file over the fence, sends an email with the CAD file and says, have fun. See you guys later. I'm clocking out. And then the manufacturing engineer takes that CAD file, will pull it apart, part by part, very, very manually figure out what order to do all of the assembly in. They'll figure out, is this thing assemblable? How would I put this thing together? They might have to, do trial and error, maybe try to build it in real life first by ordering a bunch of these parts, trying to put it together, realizing, hey, this thing's not actually assemblable. Let me go back to the CAD file. Maybe I'll make some, design for manufacturability modifications. They will then basically hide a part, take a screenshot. Hide another part, take a screenshot. Go to the shop floor, take a photo. Hide a part, take a screenshot. And that takes weeks or months. And so they'll basically take hundreds of screenshots over the course of weeks or months, throw it together into a several hundred page PowerPoint or Word document over the course of those weeks or months. And that is the modern work instruction. That is how they do it literally everywhere. You name a company, I will tell you. They have a work instruction because the whole job of a work instruction is to tell a operator or a technician on a manufacturing shop floor how to actually do a thing. The job of a factory, of a manufacturing facility, is to make a thing, and the work instruction is the guidance on how to make that thing. And so these folks are living in PowerPoint, living in Word. They're printing them out. They have like a thick white binder that sits on like an assembly station, and they open it up and they flip through, and they're like, oh, this piece of paper that's like sort of torn up and brown and wrinkled now, and it's it's been there for 3-4 years. Maybe they threw it maybe they laminated it, right? That is the modern work instruction, and that happens in all the industries that we work with, right? We work with aerospace and defense, automotive, agriculture and construction machinery, things like tractors, things you drag behind your tractor to harvest crops or harvest potatoes and whatnot. Complex mechanical machinery. This is like how everything in the modern world is built. It's built with something that looks like IKEA assembly instructions, but if you are trying to make a plane, car, engine, missile, whatever, whatnot. So that is the modern thing. That is what we are not only automating a majority of the generation of, but we will automatically figure out the sequence for your assembly. Basically, rather than it taking you weeks or months, with our software BuildOS, we like to say it is what CAD did for mechanical engineers, we are trying to do for manufacturing engineers. So in BuildOS, a manufacturing engineer will throw their CAD file. We'll basically run an assembly simulation that'll figure out what order to do all your assembly in, and then automatically generate 80 to 90% of the work instruction. We very much call it an 80-20. So we'll figure out the sequence for the assembly, and then we will generate, basically in this 3D rendered interactive environment, all of the animations step by step of each part of the process. And so that is what BuildOS is doing today. Actually, great timing for us to chat. We actually just launched the basically largest extension and module to our product to date. We call it Operator Plus. It is now basically the ability to close the loop and not just view a model-based animated instruction for an operator, but have the operator able to automatically do a time setting in the background, but basically give feedback to a manufacturing engineer. There's a lot of context and information that a operator or technician on a shop floor has that they, might sort of like offhandedly mention, or because a manufacturing engineer sort of like works in a different part of the facility, they might never actually get to tell them. This is our way to give power to the operators. That is our tagline for it. It's power to the operators. We want to help incorporate operators into the production planning process and aggregate as much context for them as possible and give them a voice back in the production planning process. So we just launched that today. Actually, as of 17 minutes ago, I think we just threw up some announcements on it. So really, really great timing. But we're really, really excited about that. It came out quite well, and it's already live at a bunch of manufacturing facilities that we're working with.
Awesome. Breaking news right here. I remember reading about when VisiCalc came out, you could basically do a month's work in 12 hours or whatever it was. I know you talk to customers a lot. I'm sure they're absolutely delighted with this product, right? It seems like a total game changer for them.
Yep. We like to see, it's actually really awesome. We advertise and we tell people like this will save you like 90-95% of your time making a work instruction. And that's a bold claim, right? Because if you say this will take you ordinarily day to day, it'll take you a month to make a work instruction for the system. If I tell you it's actually going to take you a day or two to do that now with our software, that's a bold claim, right? What's really, really satisfying to me is having people get into the app, use it, come back and say, holy shit, you weren't kidding. Like, wow, that's pretty incredible. We've seen that like on average, like 90-95% of time reduction for drafting work instruction. And also now in execution, we've seen significant error reductions as well. Because, we like to say a picture is worth 1,000 words, but an animation is worth 1,000,000, right? Every operator having in their hands the power to rotate around a model and see the parts come together in real time, that is power, right? That is the context that often folks lack and often drives like significant errors, misinterpretations, right? Imagine like you're just picture for like the non-technical person, you're putting together your IKEA furniture and you're trying to figure out how, like at what angle am I supposed to do this? What am I supposed to, just seeing that come together, interact with that model in like a 3D environment with the animations that we generate for you, it's game changing for execution. So not only are manufacturing engineers really happy because it's saving them a ton of time, but operators are also really, really happy. Operators love it. It's actually pretty insane. operators were saying that like they have to ask way fewer questions. It's way more straightforward. Like they are able to do their job more effectively. They're able to hit metrics and things that they're held to. And then production supervisors were saying like this is game changing because they have this bird's eye view of all of that. They don't have to go around and stop around the floor and peer over people's shoulders. Everything they need to know is in this runs dashboard that Operator Plus now actually tracks for you. So it's really cool.
Is there one bit of customer feedback or quote that stands out that you've gotten so far?
Ooh, we have so many anecdotes that I love. One of them, I have anecdotes on the negative side of like, what somebody is doing today and how bad it is, what they're doing today. And then I have positive anecdotes on, what we have done for them, basically, like how much their quality of life has changed with our software. I would say one of the coolest ones, it always happens after a demo video, right? We'll have an introductory call with somebody. We'll basically share a demo video with them of BuildOS and show them. And then oftentimes after that, what we'll do is we'll basically, take a CAD file from their team. We'll do a live demo of us making a work instruction with their CAD file, which is pretty crazy because, we don't work at their company. How on earth are we, folks who work at a software company, how are we able to make a work instruction for your product as good or if not better than some of the folks on your team who have been there for forever? And so we have done live demos that have had really like hilariously awesome responses from folks, especially, there's this type of person at every manufacturing facility. You call them generally like the convertible skeptic, right? There's like, he's been on the team for 20, 25 years. He's seen, random gobbledygook BS software try to get sold to him for 20 years. It's some newfangled Silicon Valley garbage. And, it doesn't actually make his quality of life better. It's been going on for 10, 15, 20 years of, another ERP, another this, another that. It's just manual stuff instead of me now, the historical thing of instead of him writing things down on pen and paper manually, oh, great, now he's manually doing it on a computer. Great. It doesn't really save him any time. It just makes management happy. And that's like the classic thing of manufacturing software. And so there's a lot of folks who have just seen and been pitched like magical software that like there's a lot of like very, very smart but very skeptical old heads that we talk to. And my favorite thing is when we end up getting them to be the champion because they'll come in, their arms crossed in the back of the room. They're super skeptical. And then, they'll see a demo, we'll walk them through it. And by the end of it, they're on their feet. And they're like, whoa, this is game changing. This is crazy. And so I have a really funny anecdote. We work with companies all over the world, right? Primarily, we say that we are operating the modern Western manufacturers. So we work with, manufacturing facilities in the US, Canada, Europe, right? So there is a Italian automotive manufacturer that we're working with. And there was a very senior gentleman on the call when we were doing a live demo with one of their CAD files, and when you're in on the instructions page, right? You're on a certain step. We don't animate for you like right initially. You can click and say, pull in the animation. This is actually something we're changing in the software. Just do it, without you having to click a button to pull the animation that we generate for you. Anyway, guy sees, half assembled system on like step, 20 out of 40. We click the accept button to pull in the animation, and this old Italian man basically says, wow, it's a magic. and I that just rings the back of my head because it's like, yeah, like actually good software is really cool. There's this old quote that sufficiently advanced technology is indistinguishable from magic. And that is just consistently the sentiment and feeling that we get from customers. And that's really gratifying and validating to me because a lot of the inspiration for building our company is deeply rooted in this sort of like Isaac Asimov's Foundation series. It's what drove my co-founder and I, Peter, to that's a large chunk of what drove us to build a company is, if we want to send 10 million humans into the stars or a quadrillion humans into the stars, how are we going to do that? Well, not on pen and paper, I'll tell you that. And so it's very cool to see people experience our software as this sort of like magical intervention towards their day-to-day dreariness. So
you mentioned Asimov. What's your favorite Foundation book?
Oh, definitely that's a good question. Have you read all of them?
I love them.
I'm not a prequel guy. I don't like the humanization of Harry Seldon. I think it's like I don't want to know. I prefer him to be this like legendary mythical figure. This is also why like I very much disliked the Apple like TV series. What did you think of that?
Yeah, I didn't even watch it, to be honest with you, because I didn't want to round the books for me.
Yeah. It just I got really upset about it because I very much like when a show comes out about a book that like stays true to the story, and they just like turned it into this weird like romance thing. And I was sorry to spoil it a little bit, but I just like, dude, like the whole point, the entire point of the Asimov series is that people don't matter. These are the waves of history moving. This is psychohistory. Literally the entire point is that the individuals don't matter. Individualism doesn't matter. There are these wider trends and ebbs and flow of history and human experience, and you're left generally intentionally detached from the personal lives of people, right? You hear about that, but the way that Asimov writes is such that like you don't become emotionally attached to people, really, even though you might find Golden Trevize to be sort of this like awesome guy or something like that. But the shows just like made it weirdly personal. They were like, no, screw psychohistory. I'm the one. Like I can change history. It's like, no, dude, you're missing the whole point of the book. Anyway, I get heated about it just because I'm like, you're literally destroying Asimov's, writing in the way that they wrote the show, and they basically just completely botched the plot. Like it was like inspired by Asimov with some of the same characters and names, but like they pulled different people. It was a mess. I didn't like it. Anyway,
last question on our sci-fi tangent: Dune or Foundation?
Sorry.
Dune, like Herbert's Dune or Asimov's Foundation. Which one do you prefer?
Oh, definitely Asimov. Yeah, definitely Foundation. Yeah. I'm it's the classic. It's part of our like Dirac team like cultural reading. There's like a book list for whenever somebody joins. I say like there's these 5 books you got to check out. Freedom's Forge is number 1. Asimov series number 2. The Chiropedia, sort of about Cyrus the Great. That's number 3. There's The Universe Speaks in Numbers by Graham Vermello. The other book by Graham Vermello, the first one being the Paul Dirac book initially. And so I'm a big fan of those 4. And then a 5th I kind of rotate out depending on like the current state of the company. So
I'm curious, automating work construction seems like a very non-obvious idea. So how did you settle on that specific idea?
So it's actually kind of interesting. We initially set out as a team to, it was Peter and I, we initially set out to go build our own factory. We were trying to do robotic assembly for aerospace systems at scale. And basically, when we went to 90 aerospace manufacturers over the course of 6 months saying, hey, outsource your assembly to us, it's going to be great. Trust us as like a contract manufacturer. All those aerospace manufacturers basically said, the factory seems cool, but that software under the hood would be game changing for our guys in the shop floor today. Can we just have it? So after a while of hearing that, we basically said, okay, might be a good place to start. So we actually ripped that assembly planning simulation software out of that robotic assembly infrastructure and built a platform around it. And that is actually what BuildOS is today.
How do we make manufacturing cool again? I mean, how do you get the next generation of kids, which I think is all already happening on the margin, but how do you get them to want to become machinists and fabricators instead of software PMs?
It's kind of interesting, right? The modern like education system has been like, if you look at like the top 20 schools, right? These are schools that for the most part like have been educating on like the brightest minds over the past couple of centuries. And then I think there was this basically like after the Cold War ended, we said globalization has won, global American empire is here, let's like outsource our economic our primary economy and our secondary economy to like other like vassal states. Effectively that became like China, Korea, Japan, and so with that came like, manufacturing work is like too dull and dirty. I want to work in like higher knowledge work, right? So computer science became like the thing to do. And also like literally at the same time, we basically made it illegal to do anything interesting or hard. in the US. A lot of, aging boomers start to like overregulate. This is what happens, like average testosterone level of like a adult male populace like drops as they age. And so those folks basically inherited like the post World War II order. Their testosterone is dropping. They try to go like very heavy on like safety and regulation around everything. And thus, led to making all like very interesting things in hardware and whatnot, like illegal to do. And so nowadays, we're sort of bringing this back, right? Everybody's waking up that like, yes, we sort of live in this like global American order currently, but like that can be threatened really easily by a hungry underdog like vassal state that like is not, just taking it. Like China is like absolutely not. They're not okay being number two, and they're hungry and they're biting at our heels. And so I would say what we've seen over the past couple of years with the reindustrialized movement, with a lot of folks saying you can just do hard things, you can work on hardware, you can work on production, is there is this like very much movement of younger, more exciting founders and investors who are talking more and more about like these are problems that we can solve. It is okay to solve them. It takes more than just you can have a lot of energy. You can be very driven towards a problem set, but it takes more than just, one or two people, yelling at the moon to make something happen. And so there are a lot of different things happening at the same time that are allowing us to do this now. What I found to do one of the greatest jobs around this is getting young folks excited about working in hardware. Everybody wants to work in hardware, really. They just don't know it yet. They have this like sentiment that like, oh, I don't know anything about robotics. I don't know anything about mechanical engineering, because like the design side has been so disconnected from the actual real world hands-on side. And so I found like as a nation, we are a nation of folks who are high agency, high autonomy. And for going through K through 12, right? 12 years of education, you're taught to be low agency, low autonomy. And so as soon as you could basically break folks out of that like mindset of you can actually just do things, you don't have to ask for permission, you can just build. That is the best way to not only unlock somebody's mind, but show them that like you don't just have to build a CRUD app or some SaaS gobbledygook, right? You can actually just work on production, you can work on nuclear, you can work on complex energy problems. Like you can do an interesting, difficult, you can build something interesting and difficult because you have decided to. You don't have to ask anybody for permission. You can just build it. So
how do you think you catch kids at that young age? Is it a case of launching a nationwide summer internship program, in all these hard tech areas? Have you thought about that?
Thought about it a little bit. It's kind of funny. Like, I'm generally pretty young, right? There's a cohort of founders in my like sort of age and friend group that are young, that know how to, communicate with the younger generations and whatnot. Like, we're on social media, we're on Twitter, right? We're on Instagram. We had, I grew up like with Snapchat and like, that is the world that like we come from. And so it's very difficult for like millennials generally to communicate effectively with like the younger generations, just because like they did not grow up with a smartphone in their pocket. But this is something that like, I generally am familiar with it. Other guys my age are familiar with. And so there's a new dialect, a new lingo, a new way in which you position ideas that make it really, that permeate like the mental membrane of like kids who are now inundated with like random bullshit, like brain rot from TikTok and whatnot. So it's about messaging effectively and signaling that like, if you want to win, if you want to be a part of something that wins, like work on American production, work on American energy. Like this is something that, boys grew up watching Top Gun and they're like, whoa, that plane was sick. I want to work on spaceships and rockets and all that cool stuff. It's the letting somebody know that you can actually do that. Partially like online messaging works really, really well around that, like verbally. But then also there are governmental things that like we're not doing today that we can be doing. This comes in line with like, generally, I think government as a vehicle for affecting social change is tough because as soon as the government mandates something, it's not cool anymore. It becomes like the anti thing. And so when, we see that the government funds funding STEM programs and all that, it's actually dangerous because it actually becomes like a avenue for somebody to do like some regulatory capture or like another, highway bandit to extract money from the government, right? Or sorry, not highway bandit, feltway bandit, to extract money from the government, right? And so that doesn't really work super well. But there are I think the best way to do it generally has been through like social means, right? Like there might be ways for government to by removing things, government can actually affect this sort of change. By pushing forward policies or frankly, invalidating and removing policies and then publicizing that and allowing a generation of founders to serve as inspiration to the next generation of young kids. Elon, great example of this. He has inspired more hardware oriented people than I can count, right? Core deep inspiration for me. I made my Twitter account when I was 12. Back in 2012, I was born in 2000, just for context. Back in 2012, I made my Twitter account just to tweet at Elon, hey, I want to help SpaceX get to Mars. This is before he was such a household name for sure. I was hey, I want to help SpaceX get to Mars. Can you hold back, could you hold SpaceX back for me? I'm only in 8th grade, but I'm going to be going to MIT to be an aerospace engineer. Spoiler alert, didn't go to MIT, but could you please hold back? And it's guys like that, right, enable us to win. And the highest calling you can have is not just to be a guy like that, in that, Elon is pushing the frontier of what is possible, but the knock-on effects, the second, third, fourth order effects of having guys like that in the limelight as winners show young people that you can be a winner too. So that's I would say being a inspiration to the next generation is the best thing you can do. Showing that you can do this and leading the way effectively.
There's a ton of energy around making American shipbuilding great again. I know you guys recently signed a deal with Fairlead. Tell me about the deal, and then what surprised you most about when you dug into the state of American shipbuilding?
Whew. Well, and I like to say shipbuilding as a industry is, if you were to sort of order how automated or how modern production verticals are, you can actually very neatly see how automated and modern they are by the rough volumes that they produce. So I'll order them in sort of this, that sort of spectrum of we make one thing a year versus we make hundreds of millions of things a year. So electronics, PCB manufacturing, all that sort of consumer electronics stuff, that's in the 100 million to billion range, right? Super automated, fully lights out factories in some places in China. And then lower quantities, you're looking at automotive. Below that, you're looking at ag and construction machinery. Below that, you're looking at aerospace and defense. And below that, you're looking at maritime. And so when it comes to maritime production, I would say you can also look at the permeation and adoption of CAD software. How CAD'd up is this industry? Automotive, basically everything's CAD'd up. Ag construction, pretty much everything, but you definitely, I would say 10 to maybe, if I was being generous, maybe 20% of manufacturing facilities just don't have CAD files. You find some that have some mixture, maybe half their stuff is CAD'd up, half isn't. And then aerospace and defense, again, pretty similar, and then maritime is generally significantly further behind that. They don't have a ton of digital tools. Hell, they don't have an ERP in a lot of places, right? They don't have CAD in a lot of places. They're still doing drawings. They're still treating it there's a reason they call them naval architects, right? That when somebody who designs a ship or designs a submarine is called a naval architect. And when you think about the words naval architect, it brings to mind a shipbuilder a person building ships you build a piece of architecture, you build a building, right? And those blueprints, those types of documents are a lot of the times very much what they're working on. And so not very digitized, very paper-based. And so that to me wasn't the surprising thing. And so with Fairlead, like actually as a company, Fairlead is actually very advanced. So I give them a lot of credit. They are, it's crazy. Like half of the people on the Fairlead team are like former submarine officers, which is, I mean, they are just a serious bunch, and they are dead serious about winning. Like they are a very, very impressive team to work with. And so what surprised me was actually, and this is kind of what I was getting at earlier, for 10 years, there was a lot of like, we need to modernize, and as a culture, we need to modernize production, and everybody was like, yeah, I've heard it, whatever, Industry 4.0, all that stuff. But over the past couple of years, since COVID, there has been this real heavy push of, oh no, like, we're not kidding, we really need to modernize. And so Fairlead moved from the day we met Fairlead to the day we signed a deal with them was less than a month, which is unheard of. Like they moved fast, right? Like typically selling software into manufacturing, average sales cycles are 2 to 3 years, like on average, selling any sort of software to any manufacturer. We're very fortunate, and then like our sales cycles are a bit shorter, right? Could be 3 to 6 months generally. And so we're still beating like industry standards by a ton. But Fairlead, because of how urgent the shipbuilding need is, said, we got the CEO, owner, president, basically all top execs aligned. We got them in the office and we said, this is the plan. This is how we're driving it. And they said, we're doing it. Let's get it. Let's do it. We're in. And these folks are like very, very, very smart, very spry. I was frankly, I was coming in expecting that, potentially it could take a little while because it's a little bit older. It's a company's been around for a while, but I was really, really surprised with the agility that they had. And I frankly am like very impressed and very excited to get to work with them.
If maybe leaving Fairlead aside for a moment, if Henry Kaiser looked at modern American shipbuilding, what would he say?
He'd be very disappointed at the volume and the rate of production. I think that I think he'd be disappointed. It's actually kind of interesting. So we have in our office, we have a couple of conference rooms. They're named after 20th century industrialists. So we actually have a Kaiser room. We have a Knudsen room. We have a Kaiser room. And so, in that room, we have pictures of Kaiser and we have some of the shipyards. And you look at that and look at just ship after ship after ship. And the amount of bodies, right? The amount of people they have working on those ships is crazy. And that was something that the average American was proud to work on and sign their name on and say, I built that ship. There was this urgency. And I think if you read Freedom's Forge, highly recommend it, talks about him as a person. That is a man who has urgency. And if you look at modern, not just shipbuilding, but if you look at shipbuilding in general, you look at other industries too, but we're talking about shipbuilding, lack of urgency. And I think that with some of the executive boards that have come out recently, there's been some, fire lit under some people's butts. And I think that that's great. But I would say a lack of urgency is probably what would upset him the most. Because I think the skill sets are there, right? People take it very seriously. They're very smart. I think he would probably be a little bit miffed and annoyed about how much regulation there is and how much like regulatory capture there is in general. But yeah, I would say those probably be his biggest objections. If you look at the shipyards he built, I'll tell you, there's a reason that you ever heard of Kaiser Permanente?
Yeah, sure.
Yep. So I mean that came out of Kaiser shipyards. Came out of him basically treating his guys really well, basically starting like an internal insurance and like medical practice effectively inside of like the shipyard so that like he could take care of and treat the guys. They were getting injured a bunch. This is common, right? But that is, I would say he'd be a little disappointed.
What do you think about the potential of AI and automation in the whole manufacturing? Maybe talk about design first or work instructions. What's the thing there? And then just thinking back to Kaiser, all those bodies in the shipyards, is the 2025 version of that robots?
Not necessarily. A part of it for sure. When I talk about tribal knowledge, when I talk about bringing manufacturability back to design, when I talk about our mission as a company, it is rooted deeply in this notion of context-aware production planning. Context-aware production planning, meaning not just having really fancy, pretty software, but context-aware production planning, driving design decision. There is this world of one-directional information flow that drops pieces of the puzzle off as you move from one person to the next. And so when you talk about context-aware production plan, that being our thesis, I like to describe the problem and our product, our platform, our solution as, you ever hear that adage, 3 blind men and an elephant?
Sure.
There's 3 blind men and an elephant, right? There's 3 blind men around an elephant. One blind man feels the trunk, says it's a snake. One feels the leg, says it's a tree. One feels the tail, says it's a piece of string. But they're all sort of represent like pieces of the puzzle, parts of the puzzle. And then when you look at like what we're unlocking is we're trying to build that deeply contextually aware realm of information, right? There's different pieces all around the manufacturing facility. There is, information on manufacturing engineer and an industrial engineer and somebody doing MRO and a technician. They have different pieces of the puzzle. And man, wouldn't it be great if different people in that operation had that context? There's context that an operator has that would be really, really critical for somebody on the design side to have. And that is what we're building. So I think the future of American manufacturing design looks a lot like taking context from the shop floor and integrating that into software that folks use for design today. So that is the deeply, deeply interconnected web that we want to drive.
What's the secret to building software for the real world that actually works?
Great question. I like to say that we as a company are incredibly good at 2 things. Some other stuff too, but mostly really 2 things. One, we build really, really close, really, really great relationships with our customers. We love our customers. We love spending time with them. We love going on site. It matters a lot to us. Everybody on our team comes from a hardware background and just pivoted their careers into software. So Trevor, who runs partnerships on our team, was a mechanical engineer at Collins Aerospace for a couple of years. Jared, who runs product on our team, he was a manufacturing engineer at this company called Hubble Power Systems. And then he was a senior nuclear engineer over at General Dynamics Electric Boat for like 7-8 years. So everyone on our team, from the folks doing sales to the folks doing product, deeply, deeply understand this problem and are able to build really close relationships and deeply understand not just the problems of, but the mindset of our customer, because we were those guys once. And so deep relationships with the customer. And then what we're also incredibly good at is building extremely problem-aware, context-aware software that very, very deeply understands a very, very specific problem set that we're trying to solve and solves it 1,000 times better than anything else out there. And so really what's at the core of it is deeply understanding who you're building for, why, and why what you're doing is going to make a significant difference. And that is our secret. It's not a secret, but that is why I think we're going to win. It's because we have those 2 things. And if anybody is going to win, it is because they will have those 2 things and probably a couple of others too.
We touched on it a little bit earlier, but just talk to me about why the idea of agency and just being able to do and build things is so important.
In this world, many people will tell you no. Many people will tell you to kick rocks. And many people will try to stop you from winning. And the ability to say, you know what, I don't really care, I'm going to do it anyway, is critical, right? You have to be willing to endure immense amount of pain, struggle, adversity, and things not working in order to win. It is just a fact of life. You need to learn an immense amount to win. And the best lesson is failure. And so agency is the driver of the learning machine that you have to be to win. As a person, as a company, just in anything you do, you have to be willing to say, I don't like the world as it is today, and I want to do something about it. And that is the only way that you win as an individual and we win as a country.
I love it. I know we're coming up on time here, Phil. Maybe you play a little fun game of overrated, underrated to finish. So I'm going to name a couple of technologies.
Sure.
You say either overrated or underrated, right?
All good. Let's do it.
AI.
Complex question. Do you want just a one-word answer, or do you want me to give a little bit of context?
You can give a little bit of context for sure.
I would say AI is it's a very general term that I dislike because it's like within AI, there's actually machine learning. Within that subset is deep learning. Within that subset is LLMs. So like LLMs, I think, are a very useful tool, right? They are a very neat piece of technology. They're very useful for a bunch of different things that we're finding out. I think AI is underrated in that not the technology itself, but the impact that it has on other things, in that it is getting people to invest more in nuclear. Like I think the broader things that it has an effect on for government to start working with technology companies. I think that is what I see AI as, not just a piece of technology, but a cascading effect of dominoes that impact a bunch of things that I think really do move the needle forward for us as a society. So that's I would say, underrated long-term impact, slightly overrated as a piece of technology in so much as the transformer.
Quantum computing.
Dangerous question. Overrated. Overrated as a technology as it is today. It's useful for a very for a subset of problems for sure, and it will there's this joke in the quantum computing industry that we're 10 years away from full-time quantum computing, and they say that every couple of years. So as it stands today, a little bit of an overrated technology set. Potential impact, I would say appropriately rated. I don't think anybody's confused about what quantum computing can do.
Blockchain.
Definitely overrated. Yeah, it's I don't want to get too deep into it. I'm not a huge crypto guy. But again, useful piece of technology. I think it's had a net negative impact on humanity, in that it has made a lot of smart people work on a lot of dumb stuff that doesn't really matter that much. So I think it's overrated, underrated is almost the wrong question to ask me as a person, because I have certain types of opinions. It's sort of net positive, net negative on society would be the better question to ask. Even though definitely if we should keep doing this stuff.
CRISPR.
Ooh, underrated. Definitely underrated. Potentially huge impact. I think that there's a lot of very interesting things that it unlocks, and again, societal implications for it will be pretty huge.
mRNA.
I actually don't know enough about mRNA to have too much of an opinion, but I think appropriately rated. I think some people have, without getting into a rabbit hole on it, I think appropriately rated. Yeah.
Safe answer. GLP-1s.
Oh, that's an interesting one. I think probably underrated for not on Ozempic here or anything like that, right? But I think it's interesting in what it has done for the conversation around weight loss. It's sort of the 5 stages of grief of it's basically the tail end of the 5 stages of grief of us as a society and the obesity epidemic, where it's we're at acceptance right now. We're we're all really fat. Let's just take some medication to make it happen, or lose some weight. Funny enough, though, it's not a fat loss drug. It's it's an appetite suppressant. It's people use it to curb addictions. Turns out fat people addicted to food. It's not a secret, right? So I think for other use cases besides weight loss, I think will be very interesting. I'm very excited. I don't know if it's something I will ever take. I kind of doubt it, but I don't like shots in general. So no, thank you. And I also don't like performance enhancement stuff. I think it's kind of cheating. The only performance enhancement I will do will just be pounding caffeine pre-workout. So I think it'll just be interesting to see what it does for people.
Nuclear.
Underrated, and it cannot be rated highly enough. I have a buddy who runs a nuclear company. I think you actually visited him, Isaiah from Valor Atomics. Yeah, that guy is going to be the one who wins, hands down, no question about it. He is going to win. And so when you think about how many people are pouring money into it. Like, yeah, it seems like a lot of people are getting really excited about nuclear as an energy source, but like the things that it will unlock for us as a society are boundless and tough to articulate to somebody who like doesn't really think about energy and civilization. Highly recommend Vaclav Smil's book on it, by the way.
Solar.
It's funny, like nuclear and solar are kind of interesting in that, like, where do you want your reactor, right? Like 1/r², do you want to be like right here, or do you want to be right here? And like the farther you are from it, like the less utilization you could have of the energy at like the source. But like you're using this, like people act like solar is some like crazy concept, or like it's some like it's so much cleaner than nuclear. It's just like, or not cleaner, but it's actually way not. Like nuclear is way cleaner than solar. But people act like it's this like catch-all to be green and environmental and all that stuff. But it's like, no, dude, you're just like siphoning off energy from that nuclear reactor up there, the sun, right? So I am way more bullish on just like cut to the chase. Let's just build mini suns. And so I think like solar is perhaps one of the most overrated technologies.
Humanoid robots.
This one will get me in trouble. I think they're cool. I'll tell you that. Like I'm like I understand what people see in them. I think they are cool. I'm an electrical engineer and roboticist by background. I will always think that they're cool. I have yet to. I think you can make the economics work. I think you can make the technology work. I think that you can make the social impact and aspect of it work. But like, if you can make the economic aspect of it work, like in a manufacturing facility, like I would just want more specialized equipment. I would want like hyper specialized production equipment that is vastly reconfigurable. And I think that there are better form factors for that are a lot simpler than like a humanoid robot. Even though like, yeah, it's a complicated one. I think, because of all the pluses and all the minuses, I would say like appropriately rated.
Drones.
That's a very big and generic one. I would say appropriately rated. Like I don't think anybody's there. I have a couple of friends who work on drones in various capacities, and I think they are the smartest guys I know. And I think that they wouldn't be working on problems that utilize drones, and in a way they would not be solving the core problems that they're solving, where a drone is the solution to that problem if it were not the most intelligent utilization of that technology. Or like Augustus, for example. Augustus is using drones to cloud seed. Soren and Olaf over at Neros, right? Like they're using drones for defense. And companies
Same.
yeah, exactly, right? Like companies like Picogrid are using drones for like reconnaissance effectively. Companies like Anduril are using drones for defense, right? It's a very good application of technology, right? So,
Few more robo taxis.
it's kind of an interesting one. I don't think people are indexing on it enough. I think like, okay, do you want your train to be connected to other train cars or not? Right? Like I think underhyped. I think it'll be very interesting and useful when it comes out.
And maybe the last one, the final frontier. What are you most excited about in space?
Ooh. I mean, like the easiest answer for me is like interplanetary colonization. Like I think we need to start setting up moon colonies, Mars colonies. I think we need to start leaving the solar system with humans on those vehicles. I think we need to start having nuclear power propulsion. Like I think like there might be like some decisions to be made about like where you do that kind of stuff. Yeah, I mean, interplanetary exploration and colonization is kind of like the thing I'm excited about for sure. I think we're like slightly far out from it, but like hell, that is the great next foray into the expanse is literally a foray into the expanse. So
got to reopen that frontier, right? Phil, thank you so much for your time. Where can people find more out about you and Dirac?
So, very easy to reach on Twitter or on our website. So you can feel free to reach out to us on our website at diracinc.com. So DIRACINC.com. Reach out to contact@diracinc.com. That email goes straight to me. It is actually an alias for my work email. So if you email contact@diracinc.com, you are contacting literally me. And then my Twitter handle is FILARONS, Phil Aarons. So feel free to ping me there, and I'm fairly responsive.
Awesome, Phil. Well, again, thank you so much for your time, and hope we can do it again soon.
Yeah, likewise. Thank you for having me. It's fun. I will looking forward to doing it again soon.